I am Akshata Patil, lecturer from the Department of Mathematics, KLS VDIT Halyal. So in last class we have discussed examples using Euler's equations. Okay, so in last class I have solved 3 examples by using Euler's equation. Okay, so in today class let us solve some more examples based on Euler's equation. So let us take example number 4. Let us take example number 4. Find the curve. Find the curve on which the functional integration over 0 to pi by 2 y dash the square minus y square plus 2xy into dx with y of 0 which is equals to y of pi by 2 which must be equals to 0 can be extremized. Now in this particular question they are asking to calculate the functional by using the integration. The function they have given integration over 0 to pi by 2 y dash the square minus y square plus 2xy into dx, and they have given condition here. So that is y of 0 which is equals to, means here x is 0, y is also 0, x1 is 0, y1 is also 0, and here x2 is pi by 2, y2 is 0, can be extremized. Okay, now let us solve this example here. So here we can write, we know the functional. How to define the functional is nothing but f of x comma y dash. Okay, so here we have compare the given function with the functional. Okay, so here we can write f of x comma y dash is nothing but functional which is compared to the given function, that is y dash the square minus y square plus 2xy. Okay, plus 2xy. Now we know the Euler's equation. So here we can write, let us by the Euler's equation. By the Euler's equation, okay, that is dou f by dou y minus d by of dou f by dou y dash which is equals to 0. We already know, we have proved this theorem, that is Euler's equation. Okay, we have already done this one. So here in this particular example we have using this equation, Euler's equation, that is dou f by dou y minus d by dx of dou f by dou y dash which is equals to 0. Okay, now just observe this above function. In this function dou f by dou y, is it y term is there in this function? Yes, the second term and third term is having y term. Okay, so here we can write dou f by dou y means here minus y square differentiation with respect to y. So here you will get minus 2y plus 2x constant term keep as it is. This y differentiation with respect to y means 1. So here you will get minus 2y plus 2x minus d by dx of dou f by dou y dash. Now again observe this function. In this function y dash is there. Yes, here y dash is there, the first term which is having y dash term. So you have to differentiate this y dash square with respect to y dash. So you will get here 2y dash which is equals to 0. Okay, I hope you understand how to get minus 2y plus 2x and minus 2y dash. Okay, dou f by dou y means in this function you have to differentiate y terms with respect to y, and y dash means dou f by dou y dash means in this above equation you should differentiate y dash terms with respect to y dash. Okay, so here we'll get minus 2y plus 2x minus d by dx into 2y dash which is equals to 0. Here in each term having 2, is it right? So what we should do, I will take that 2 term outside and shift it to the RHS side, then it becomes 0. So here we will get minus y plus plus x minus d by dx of y dash is nothing but y double dash, which is equals to 0. Okay, I hope you understand this step. Now let us shift this minus y double dash and minus y to the right hand side. Then you will get here y double dash plus y, which is equals to x. So this is nothing but, we call it as second order ordinary differential equation. Is it right? Yes, this is a second order ordinary differential equation which we have already studied in second semester. That is linear differential equation. Is it right? So we know linear differential equation actually having two types. That is homogeneous linear differential equation and non-homogeneous linear differential equation. But this particular example equation is non-homogeneous linear differential equation. Is it right? This is non-homogeneous linear differential equation. So we know how to solve non-homogeneous linear differential equations. Is it right? So here we using differential operators. We know differential operators. So using differential operators. So that is, here we can write y double dash means d square plus 1 into y, which is equals to x. Okay, now here I need to calculate auxiliary equations. Auxiliary equation means what? Wherever differential operator that d is there, replace it by m. So here we can write m square plus 1, which is equals to 0, or we can say m square, which is equals to minus 1, or this implies we can write, I want only m here. So m, which is equals to plus or minus root of minus 1. So that is nothing but plus or minus I. Root of minus 1 is nothing but I. Okay. So here the roots are complex. Is it right? The roots are complex. The roots are complex means how to write complementary function, which is equals to, complementary function means alpha plus or minus I beta. What about alpha here? Alpha is 0. And what about beta here? Beta is 1. Okay. So here we can write complementary function, that is a into cos of beta x. Beta is 1. So we can write here a cos x plus b sin x. Okay. A cos x plus b sin x. So this is our complementary function. I hope you remember all these one. We already done this one in second semester. Okay. So complementary function is a cos x plus b sin x. So next step is what? After finding this complementary function, we need to find particular integral here. So particular integral means we know the formula here, that is 1 divided by f of d into this phi means non-homogeneous function. So here we will write x divided by f of d is what? D square plus 1. So we can write d square plus 1. So this is what? This is a type 3 example. Okay, so this is a type 3 because here the function which is having a right hand side value, that is polynomial, which is in the form of polynomial. So we know how to solve the polynomials. So the only thing, by using the division method, we should get this particular integral of this particular function. Okay, so by only the division method we should solve this equation and we'll get the particular integral. So we know that one, how to calculate division, how to apply the division method. Is it right? So here we'll get particular integral of x divided by d square plus 1 value is x only. Okay, so we know. So I will not do that part, division method. You should know how to solve type 3 examples, which we have already done in the second semester. Okay, so here by division method only we should calculate the given function x divided by d square plus 1. Then after calculating a division method, we will get particular integral is x here. Okay, so we can write here, so we can write complete solution. Complete solution is capital Y, which is equals to complementary function plus particular integral. Complementary function is what? A cos x plus b sin x plus particular integral is what? X. Okay. Now, in this particular question, they have given here some initial condition, that is y of 0 which is equals to y of pi by 2 which is equals to 0. Okay. So let us get it here. Let us write using the condition y0 at x0 and y equals to pi by 2 at x equals to pi by 2. Okay, at x equals to pi by 2. Now let us substitute these conditions in above equation here. So you will get here, that is, now y equals to 0. Y equals to 0, that is 0. Is it right? Put y equals to 0, which is equals to a into cos of x is 0. X is 0 means cos of 0. Cos of 0 value is here 1. Okay. Now plus b into sine of 0. Sine of 0 value is 0 means that the term b should be 0 only. Plus this is 0. So here you will get capital A equals to 0. Capital A equals to 0. Similarly, and also put y equals to pi by 2. Now, just observe here. Y equals to pi by 2. Pi by 2. Okay, y equals to pi by 2. Pi by 2 equals to what? 0 only. So, 0 which is equals to a into cos of pi by 2. Cos of pi by 2 value is 0 plus b into sine pi by 2. Sine pi by 2 value is 1. So, here you will get b. Okay, b plus pi by 2. Okay, b plus pi by 2 means here I shifted that pi by 2 the right hand side, then it becomes b equals to minus pi by 2. So here you will get b equals to minus pi by 2. Okay, therefore here we can write y equals to, let us substitute these values in this above equation. So you will get this term is 0 and here you will get a minus pi by 2. B is minus pi by 2. So here we can write minus pi by 2 into sin x plus x, or we can write y equals to x minus pi by 2, x minus pi by 2 into sin x. So this is nothing but the extremal of a function. I hope you understand this example number 4 here. Okay. Now let us move for another example. Example number 5. Find the extremal of the functional. Find the extremal of the function integration over 1 to 2 square root of 1 plus y dash the square divided by x into dx under the condition y of 1 which is equals to 0 and y of 2 which is equals to 1. Y of 2 which is equals to 1. Okay. Now this is a given question. What they have given? They have given integration here. Integration over 1 to 2 square root of 1 plus y1 the square divided by x into dx. And they have given conditions here. Y of 1 equals to 0 and y of 2 equals to 1. And they are asking to calculate extremal of the functional. Okay, now let us solve this example. So in given, we know the functional, that is f of x comma y dash. Now just compare this function with this functional. So here we can write square root of 1 plus y1 the square divided by x. Okay, now using Euler's equation here. So by Euler's equation, we know dou f by dou y minus d by dx of dou f by dou y dash, which is equals to 0. Okay. Now just observe this above function. In this function, is it y term is there? No, here there is no y term in this function. Okay, it means dou f by dou y must be 0. So here we can write 0 minus d by dx. Okay, d by dx. Dou f by dou y dash. Dou f by dou y dash means you have to differentiate this term y dash with respect to y dash. Okay, so here square root of 1 plus y dash d square divided by x is there. Okay, so what is the differentiation of square root of 1 plus y1 d square? Root x differentiation is 1 divided by 2 root x. Is it right? So here we can write 1 divided by this x keep as it is into 2 root x into 2 root x. Again, this y dash square differentiation is 2 y dash. Is it right? Okay, that is 2 y dash, not here, that is 2 y dash. Okay, so 2 y dash square. So 2 y dash square means 2 y1 dash. Y square differentiation is 2y. So here we can write 2y1 y dash. Okay, so which is equals to 0. Now here this 2 get cancelled. So the left of the portion is what? D by dx of y dash divided by x into square root of 1 plus y dash d square, which is equals to 0. Okay, now we know the integration here. Here you will get minus dx d by dx of y dash divided by x into square root of 1 plus y dash d square. So we know the integration of the differentiation of the sum function will be the function itself. Okay, so here we can write that is y dash divided by x into square root of 1 plus y dash d square, which is equals to some constant c1. Okay, why this is d minus d by dx, it becomes what? Function itself. The integration of the differentiation of some function will be the function itself. Okay, so that's why here we can write, therefore here we can write y dash divided by x into square root of 1 plus y dash d square, which is equals to some integrating constant c1. Now here what I should do? Squaring on both sides. Okay, squaring on both sides. So here we will get y dash d square. Okay, y dash d square, and here squaring means this shifted to the right hand side. So we'll get here that is c1 the square x square into square means this becomes what? 1 plus y dash the square only. 1 plus y dash the square. Now simplify it here. Y square, which is equals to c1 the square x square. Multiply this one to the inside the term. So you will get c square, c1 the square x square into 1 is c1 the square x square, plus here we will get c1 the square x square y dash the square. Okay, now shifted the c1 x square y dash the square to the left hand side. So you will get y dash the square minus c square c1 the square x square y dash the square, which is equals to c1 the square x square. Okay, now here I will take this y dash square common outside. So here you will get 1 minus c1 the square x square into y dash the square, which is equals to c1 the square x square, or we can write y dash the square, which is equals to c1 the square x square divided by 1 minus c1 the square x square. Okay, 1 minus x square. Or here I want only y dash term, so y dash which is equals to c1x divided by square root of 1 minus c1 the square x square. Okay, because I don't want this square here, so we will get here y dash. So y dash equals to c1x divided by square root of 1 minus c1 the square into x square. We know this y dash is nothing but what? Dy by dx. So dy by dx, which is equals to c1x divided by square root of 1 minus c1 the square into x square. Now using the separation of variables here, so therefore we will get dy which is equals to c1x divided by square root of 1 minus c1 the square into x square into dx. Okay. After this one, integrating the terms here, integrating. Okay, so here we can write, just observe here, integrating. So let us write this equation y which is equals to integration c1x divided by square root of 1 minus c1 the square x square into dx. See here this function, integrating this function. So integration of dy is y. So here y which is equals to integration c1x divided by square root of 1 minus c1 the square x square into dx. So that's why I have written here integration c1x divided by square root of 1 minus c1 the square x square into dx. Now use some substitution method here. So put c1x which is equals to t. c1x which is equals to t. This implies c1 dx which is equals to dt. What about dx here? Dx which is equals to dt divided by c1. Now let us substitute this one in the above integration. So you will get y which is equals to integration. So here just observe here x dx. So x dx is there or dx is there. Okay, so here we can write c1 dx. This c1 dx is nothing but dt. Okay, so here we can write that is 1 divided by c1 into t dt divided by square root of 1 minus t square. I hope you understand here. What about dx here? Dx is nothing but dt by c1. So here we can write dt by c1. Okay. And what about the remaining term here? c1x. This c1x is nothing but what? T. So here we can write t into dt divided by c1. Okay. Into square root of 1 minus c1 the square x square is nothing but t square. So here we can write 1 minus t square. Okay. I hope you understand how we can write this one. Okay. Now afterwards let us write here. I will take the common here the term. Okay, so we can write here that is 1 by c1. So integrate this term here, t divided by square root of 1 minus t square. T divided by square root of 1 minus t square. Okay, so here we will get minus 1 by c1 into square root of 1 minus c1 the square into x square plus some integrating constant c2. Okay, some integrating constant c2. I hope you understand how we will write this one. Integration of t divided by square root of 1 minus t square. Okay, so that is nothing but minus that is minus root of 1 minus t square. T is what here? c1x. So that is c1 the square x square. Okay, here c2 is nothing but some another integrating constant.
Screen is not visible.
Hello?
Ma'am, screen is not visible.
Just a minute. Now it is visible.
No, ma'am.
Now it is visible.
No, ma'am.
No, ma'am.
See now.
No, ma'am. Ah, yes, ma'am.
Yes,
Is it
ma'am.
visible?
Yes, ma'am.
Okay. Now here we will get y equals to minus 1 by c1 square root of 1 minus c1 the square x square plus of some integrating constant c2. Now what I should do? I have shifted this plus c2 to the left hand side. Then it becomes y minus c2 which is equals to y minus c2 which is equals to minus 1 by c1 into square root of 1 minus c1 the square into x square. Now squaring on both these sides, squaring on both sides, squaring on both sides. So we will get here y minus c2 the whole square which is equals to 1 divided by c1 the square minus of, okay, minus of x square, minus of x square. Why I am using this here? Because the square root of 1 minus c1 the square x square is there. Now squaring, and you should multiply this 1 by c1, simplify this one, we will get 1 by c1 the square minus of x square here. Okay, now shifted this minus x square to the left hand side, then it becomes x square plus y minus c2 the whole square which is equals to 1 minus 1 divided by c1 the square. Okay, now using the conditions here, using the above conditions, using the above conditions, that is what they have given conditions here. They have given y equals to 1 which is equals to 0, y equals to 2 which is equals to 1. Okay, now let us substitute the values here. Y of 0 which is equals to 1 and y of 2 which is equals to 1. Okay, now you have to substitute the values here. So y of 0, 0 means x is 0 and which is equals to 1 means y is 1 here. This is 0 the square plus 1 minus c2 the square, okay, which is equals to 1 minus c1 the square. Okay, and again you should use y x equals to 2 here and y equals to 1 and simplify it. So finally you will get here c2 equals to 2 and c1 equals to 1 divided by root 5. Okay, 1 divided by root 5. Now let us substitute the value of c1 and c2 in this equation again. So you will get here therefore x square plus y minus 2 the whole square which is equals to 1 by c1 the square means 1 by root 5 the square is 5 here. So this is nothing but we can write this is the extremal of the given function which is a circle, which is a circle. Okay, so this is the extremal of the given function which is a circle having the radius 2 and 1 divided by root 5. Okay, so this is another one of the important example I have solved today. Okay, so let us solve one more example. So this is nothing but the fifth example. Now let us solve another example here. Sixth example, find the curve on which the functional integration 0 to 1 y dash the square plus 12xy into dx with y of 0 equals to 0 and y of 1 which is equals to 2. Y of 1 equals to 2 can be x3 can be determined, can be determined. Okay, now in this particular example they have 0 to 1 y dash d square plus 12xy dx. They have given two initial conditions, y of 0 equals to 0. It means x is 0, y is 0, and y of 1 equals to 2. Again here x is 1 and y is 2 can be determined. Okay, so let us write here, let capital I integrating which is equals to 0 to 1 y dash d square plus 12xy into dx no, here we know that is a functional f of x comma y dash, which is comparing with the given function, that is y dash d square plus 12xy. Now by using the Euler's equation, that is dou f by dou y minus d by dx of dou f by dou y dash, which is equals to 0. So this is a Euler's equation. So in this above equation, in this above function, is it y term is there? Yes, the second term which is having y. So what about dou f by dou y? It means you should differentiate this second term with respect to y. So here you will get 12x, because y differentiation with respect to y, it becomes only 1. Okay, so 12x minus d by dx of dou f by dou y dash, means this first term y dash d square you should differentiate with respect to y dash. So here you will get 2y dash d square differentiation is 2y dash, which is equals to 0. Okay, which is equals to 0, or here we will get that is 12x minus d by dx of 2y dash differentiation with respect to x, that is y double dash, is it right? So here you will get 2 into y double dash, which is equals to 0, or we can say that is y double dash, which is equals to 6x, is it right? So y double dash, which is equals to 6x. Y double dash is nothing but what? D square y divided by dx square. Okay, y double dash is nothing but d square y divided by dx square, which is equals to 6x. Now what we should do here, and integrating with respect to x, and integrating with respect to x, and integrating with respect to x, then we will get d square y divided by dx square becomes dy by dx here, is it right? So after integration of this function d square y divided by dx square, we will get here dy by dx, which is equals to integration of here 6x dx plus of c1. Okay, or here we will get here integration of 6x, integrating this one with respect to x integration is x square by 2, 2 ones are 2 3s are, so here we will get that is 3x square plus of c1. Therefore we can write dy by dx, which is equals to 3x square plus c1. Okay, so again integrating this one, so we can write again integrating with respect to x, again integrating one more time with respect to x. So we will get here that is dy by dx integration with respect to x, means you will get y which is equals to, okay, 3x square plus c1 into dx plus of c2. Okay, now y which is equals to integration 3x square integration, that is x square integration with respect to x is x cube by 3. X cube by 3 means 3 get cancelled, so remaining you are getting here x cube plus c1 constant term, here 1 into dx is x, is it right? So here we can write x into c1 plus of c2. Okay, so here you will get some solution, that is y equals to x cube plus x c1 plus of c2. Now here we using the above conditions, what is that? Y equals to 0 at x equals to 0, and one more condition, y equals to 1 at x equals to 1. Just see here, they have given y equals to 0, y equals to 0 which is equals to 0, and y equals to 1 which is equals to 2. So here I have written y equals to 0 which is equals to 0, means y 0 at x equals to 0, y equals to 1 which is equals to 2, is it right? Which is equals to 2. So here we can write y equals to 1 at x equals to 1. Okay, so let us substitute, sorry, this is 2. This is 2 at x. No, y equals to 2 at x equals to 1. Okay, at x equals to 1. Now let us substitute the conditions here. So we will get here, just observe this equation. First put y equals to 0 at x equals to 0. Y is 0, x is 0. This one is 0. Then what about C2 here? You will get C2. So let it write, put y equals to 0 at x equals to 0. Y equals to 0 at x equals to 0 means this one is 0. X is also 0. Here x is multiplied with the C1 means this term also 0. So here you will get C2. C2 which is equals to 0. C2 which is equals to 0. And y equals to 2. Y equals to 2 at, sorry, y equals to 2 at x equals to 1. At x equals to 1. Now let us substitute here. Y is 2. This is 2. And here you will get 1 the cube plus 1 into C1 is C1 plus of 0. So here you will get C1 plus 1 which is equals to 2. Is it right? So here you will get C1 y is 2 which is equals to 1 plus C1 plus of 2. So here you will get C1 which is equals to, this one shifted to this side. So you will get 2 minus 1 is 1. So C1 equals to 1. C1 equals to 1. Okay. Now thus substitute the values in this above equation. So y equals to x cube plus x into C1. See, what is here condition? Y equals to x cube plus x. C1 value is how much? 1. So here we can write here into 1 plus C2 is 0. So here we will get y equals to x cube plus x. Okay, x cube plus x. So is the required curve. Okay, so this is the required curve of given integral function. I hope you understand this example here. Okay, so in this Euler's equation, I have solved 6 examples based on Euler's equation. Okay, so the lot many examples they have given in the book. Just try to solve the remaining examples. If you are getting any difficulty, please contact me. Okay, so in next class means tomorrow I will move for the last concept of this subtopic, that is a standard function, what do you say, that is standard variational problems, that is geodesic and hanging chain is there. Okay, so in tomorrow session I have complete that portion, means I have complete the module 5. Okay, so I hope you understand the today class. So the rest of the portion we will teach on next video. Okay, so thank you.